you'll start seeing these. And they'll start asking you what's the square root of something, what's the cube root of something, and all of that. So let's go through a couple of these real fast. And most of these do not require a lot of work. For example, number 1, they want to know what's square root of 49? 7. We done. What's the square root of 81 over 100? 9 over 10. What's the cube root of 64? Why 4? 4 times 4 is 16. 16 times 4 is 64. Right? So no problem with those. Number 4 says square root of this. Square root of 25 is what? 5. The square root of x4 is x squared, and the square root of y squared is y. So you're done with those. So those are pretty straightforward. Now, number 5. What about number 5? What is the fourth root of negative 1? You say nothing. What does that mean? Not a real number, exactly. Because there's nothing times itself 4 times that will give you negative 1. In other words, you can't go negative 1 times negative 1 times negative 1 times negative 1 and get negative 1. You can't get it. So you would say does not exist or not real. Everybody puts something different. I think on this test it'll say not real. And that'll be it. Now, this one, you will have one like number 6. So let's pay attention to this real quick. Number 6 says, what is the square root of 200, x to the 7th, y to the 5th? Now, so the first question I would ask you is this. Is 200 a perfect square? Can I multiply two numbers together, two whole numbers, and get 200? No, right? And I'll ask you the same question for x to the 7th. Is x to the 7th a perfect square? No, because you can't multiply two of the same, and one number times itself and get x to the 7th. Same thing with y. So I like to do mine like this. I like to break it down into 2 pieces. And again, everybody does it different. Just depends on who teaches, this particular topic. All right, so name the perfect squares for me real quick. 1 times 1 is 1. Yeah. 2 times 4, right? We're talking about 1, 4, 9. Keep going. 16, 25, 36, 49, 64, 81, 100, and so on, right? And the perfect square variables, what are they? Maybe I'll write these down. X times x is x squared. X2 times x2 is x4. X6, x8. Do you see a pattern? What can you say the pattern is? Multiples of 2, right? So anything that's a multiple of 2 is a perfect square. All right, so we know x7 is not perfect and y5 is not perfect. And we also know 200 is not perfect. So here's my question. What's the largest perfect square that does divide into 200? 100, right? So we can write 200 as 100 times 2. And notice I'm kind of separating. I'm putting the perfect squares on one side and the other stuff is not perfect on the other side. So I got 100 times 2. That takes care of 200. How about x to the 7th? Is this perfect? No. So what's the largest perfect square that goes in x7? x6. Very good. So we'll write that as x6 times x. Because x6 times x1 is x7, right? And what about y5? Thank you. Very good. y4 times y. All right. So if you notice, I have 2 sets of radicals there, 2 radicals rather. And in one radical, everything is perfect, and in the other radical, they're not perfect. So now all we got to do is go back to the first one and take it out. So what's the square root of 100? 10. So that takes care of the 100. What's the square root of x6? x3. Very good. That takes care of that. What's the square root of y4? y2. That takes care of that. And then what are we left with? Square root of 2xy, and we're done. Y'all get that or no? Y'all like to see another one of those or keep moving? Want to do another one? Somebody said keep moving. Let me do another one real fast. Try to make up one real quick. Let's see. How about if we do... All right, so what if we had that? 48, a to the 9th, b to the 15, real quick. I'm going to make 2 radicals rather. Okay, so what is the largest perfect square that goes into 48? Remember we got 1, 9, 1, 4, 9, 16. Well, we got to go in evenly with no divide. It has to go in evenly without a remainder. What is it? It's bigger. 16, right? 16. So we can rewrite 48 as what? 16 times 3. But 16 is what? Perfect. 16 is perfect. So 16 times 3. Now we got an 8, 9. Is that perfect? No. So we break it down to be what? A8 times A1. Y'all kind of get it or no? Yeah. No? Okay. If you look up here, the perfect variables are going to be multiples of 2. It has to be 2, 4, 6, 8, 10, whatever. So you look at that 9, it's not perfect. But the biggest one that goes into it is the 8. So I can write A9 as A8 and A1. Because when you put those together, you get A9. But the largest one that goes into it is A8. Okay, now look at the B15. Is that perfect? No. So we got to find the largest one that goes into B15. B14. Very good. And then plain B. So now you get it. Okay. All right. Now, if you look at the first radical, those things are both perfect. Everything in there is perfect. So the square root of 16, 4, the square root of A8, A4, very good. The square root of B14, B7, very good. That takes care of that whole first radical. The second radical just comes down. Square root of 3AB, you're done. And I'm sure you'll have one like that on the test. That make sense? All right, let's keep moving. Okay, now the next thing you'll have to do, and I'll just do one of these. So let's do, well, all right, I'll do number 8 real quick. Number 8 is asking you to multiply radicals. Now remember, they're going to be asking you to simplify radicals, multiply radicals, add radicals, subtract radicals, divide radicals. So right now we need to multiply them. So if you look at number 8, what method are we going to use? We're going to do the FOIL method, right? We're going to do the FOIL method. So the FOIL method says we're going to take what? 2x, and we're going to multiply it times 2x, right? So what do we get? Who? 4x squared, right? Don't make that mistake. 4x squared, right? Don't make a simple mistake. That's what a lot of people make. Real simple mistakes that will get them. So 2x times 2x is 4x squared. That's our first. Then our outer is what? 2x times negative square root of 5. That's going to be negative. Very good. Negative 2x square roots of 5. Y'all got that? Okay. And then we're done with F and the O. The I. Same thing. That's going to be plus 2x square roots of 5. Right? Okay. And then the last thing we have is what? Square root of 5 times negative square root of 5. That's going to be negative square root of 25, which we know is what? 5. So we know the square root of 5 times the square root of 5 is 5. And you what now? Yeah, because I teach my students that if you had the square root of x times square root of x, that's always equal to x. Whenever the two things in the radical are the same, you don't have, I mean, you could do this and say the square root of x squared.
That's fine, that's fine.
Oh, okay, I'm sorry. I'm getting on your nerve or something here? You're like, shut the hell up and move on. All right. All right, so now, the middle terms can't cancel. So what are we left with? 4x squared minus 5, and we are done. Got it? Okay, now let's look at the, let me look at number 10 real quick, and then I'll do 11, and we'll move on from there. Okay, number 10, you're still going to be multiplying radicals, but number 10, we don't do the FOIL method. Instead, we're going to be doing distributive property, right? In other words, we're going to take the 5 square root of 2, and we're going to multiply that times the square root of 8. So let's do that real quick. All right, 5 square root of 2 times square root of 6. We multiply that together, we get what? 5 square root of 12. The rule is you can multiply radicals as long as the indexes are the same. That's the rule. As long as you're in other words, if you have the square root of 2 times the square root of 7, you can go ahead on and multiply those and get square root of 14. But if you have the square root of 2 times the cube root of 7, you can't do anything with that because the indexes are different. Right? Okay, so 5 square root of 2 times square root of 6 is 5 square root of 12 minus 5 square roots of 16, right? And I'm almost sure you'll have one like this on the test as well. Now, we're not done because that square root of 12 can be simplified. It's just like if you had a fraction 4 over 8, you'd have to simplify it. So how do we simplify square root of 12? You got to break it down into two pieces like we did earlier. What's the square root of 12? 4 and 3, very good. 4 times 3, right? And we already know the square root of 16 is just plain 4. Y'all follow me? All right, what's the square root of 4? And what do we do with that 2? Multiply it times the 5. So 2 times that 5 is going to give us 10 square roots of 3 minus 5 times 4, 20, and you're done. Yeah. So you distribute, and then you look in your radicals and see if you can take them any further. And if you can, you got to break them down into pieces, and then you then you move on. All right, so let me do number 11, and then we can move on because you really need to get this concept down. Square root of 27. The question is that perfect? Is 27 perfect? No, right? So we need to break this down into two pieces again. So what two pieces are we going to use? 9 and 3. Very good. 9 times 3. All right, 75. Is that perfect? So break it down into two pieces. What is it? Yeah, right. 25 times 3. Very good. And 48. Is it perfect? So let's break it down. What is it going to be? 16 times 3. Okay, so what I've done is I've gone through and taken each one of these radicals and broke them down into pieces, right? Now, everything in front is what? What do you notice about the numbers in front? They're all perfect, right? So the things that are perfect can come out of the radical. The square root of 9 is 3. So you got 3 square roots of 3. Plus square root of 25 is 5 square roots of 3. Square root of 16, 4 square roots of 3. You can add radicals as long as the index and the radicand are the same. All right, so we got 3 of these and we got 5 of these. That makes how many? 8 of them. 8 of these. Take away 4 of these. And what are we left with? 4 of these. 4 square root of 3. Does that make sense? All right, we're done with that. That's how you multiply, add, and subtract radicals. Now we need to look at how you divide radicals. Look at number 13 real quick. Now these are pretty straightforward. You ought to hope they give you a couple like this. And I know for sure you'll have one like this. Okay, the directions will say on the test, it will say rationalize the denominator. Now what that means is they do not want a radical in the denominator. They want you to get rid of it. Here's how you get rid of it. Whatever the denominator is right here, square root of 7, we're going to multiply top and bottom by square root of 7. So just trust me on that because there are other things you can do, but that's what we're going to do right now. We're going to multiply the numerator and the denominator by the square root of 7. All right, so when we multiply straight across, that's the way we do fractions, right? What do you get at the top? You get 3 square roots of 7. And at the bottom, square root of 7 times square root of 7, square root of 49, which is 7, and you're done. And you will have one like that on the test. And so 14, we don't need to do that. It's the same thing. On 14, just tell me what would you do on 14? You'd multiply top and bottom by square root of 11. And that's all you would do. That make sense? All right, let's move on to number 8. Finding the distance between 2 points. You'll probably have one on a test like this. You have to use the distance formula. The distance formula says that the distance is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That's the formula that you have to remember. They don't give formulas, Vicky, do they? No. Okay, so you got to memorize the formula, and I can assure you that you'll have a distance formula problem on that. All right, so how do we do it? All right, so the first thing I would do if I were you is I would label my x's and my y's, And it doesn't matter which one you call x1, y1, and what. I like to say this is my first point, so that must be x1 and that must be y1. I'll call the second point x2 and y2. Now, and you can do that vice versa. You can name this one x2, y2, and this one x1, y1. That doesn't matter. It'll work out the same either way. Okay. So now I'm going to just let you tell me what to plug in. Tell me what to write. I will shut up. The square root of 8. Y'all agree with that? All I'm doing is plugging in numbers into a formula. All right, so let's see what we got here. 8 minus 5 is 3. 3 squared is 9. Not 6, huh? I heard you back there. 13 minus 9 is 4. 4 squared is 16, right? Square root of 9 plus 16 is really the square root of 25. The distance from these 2 points, 5 units. And you will have one like that on the test. Now, what you have to be careful of with a problem like this, if it's one, had this been, let's say this would have been a negative 9. Let's say that would have been a negative 9. Then you would have had to go 13 minus negative 9, right? Which would have really been 13 plus 9. So be careful of that, because that's what they might do in a test, make one of those negative. And if they make one of those negative, it changes everything. All right, so that's that. Okay, now let's move on to section 9. Okay, you will see these on the test. This will be towards the end of the test. 125 to the 1/3 power. Now, all of us know what to do if we had 3 to the 4th power, don't we? If we had 3 to the 4th power, we would simply go what? 3 times 3 times 3 times 3, which is equal to 81. So we all know what to do when the exponent is a whole number. But what in the world do we do when the exponent is fractional? Okay, this is the way we work these. Let me give you a rule. Here's my rule. Anytime you have x to the m over n power, in other words, whenever you have a base and you have an exponent that's fractional, the denominator becomes your index and the numerator becomes your power. Y'all understand that? Whatever your denominator is, that becomes your root. So like if your denominator is 5, it becomes the 5th root. If your numerator is 2, then you square everything. So y'all kind of got that? All right, so now let's do the problem then. So the problem here is 125 to the 1/3 power. Well, what is the root? The denominator is 3, right? So we're really dealing with what? The cube root of 125 to the 1st power, to the 1 power, right? The cube root of 125. But what's the cube root of 125? 5, and 5 to the 1st power is 5. So you're done. That's all you got to know, is that your denominator becomes your index. All right, so let's do number 2 real quick. Okay. All right, now, let's do number 2 real quick. Now we got another problem here. On number 2, not only do we see a fractional exponent, what else do we see? We got a negative. So each one of these things has a role to play. The role of the denominator is to do what? It becomes what? The index. The numerator becomes the power. What does the negative do?
Treat it as a positive until you get your answer and then you do something.
Oh, that's the way. Okay, okay. So your teacher treats it as positive first, then flip it later. Yeah, right. I always flip it first, but if you don't mind, I mean, no. Her teacher teaches where you ignore the negative in the beginning and do it like we did this one, and then at the end flip it. But all we need to know is that the negative actually flips a base. So the way I start is I say, okay, I got 27. So I'm going to go ahead on and flip that and get 1 over 27 to the 2/3. Now, it may be better to leave it as 27 and flip it at the end. I don't know. It just depends. You do it either way, whatever works. But in any event, that negative exponent simply means you're going to have to flip something eventually. You can flip it in the beginning or flip it at the end. Either way, you're going to have to flip it. All right, so this 3 becomes what? What's that 3 become? The index, which will become the cube root of 1 over 27 raised to the what power? Second power. That will become the cube root of 1 over 27 to the second power. Well, what's the cube root of 1? 1. What's the cube root of 27? 3. And then all of a sudden you got to square this mess. 1/3 times 1/3. 1 over 9. Had she done it, she would have got 9 as the answer. Then at the end, she would have flipped it over and still got 1 over 9. So it works out either way. Does that make sense? All right. So let's keep moving. Now, number 3 says, I got x to the 3/5 times x to the 1/2. I'm doing number 3, section 9. Okay. If I were to ask each of you right now, what is x to the 3rd power times x to the 5th power? All of you would say x to the 8th power, right? And how did you get the 8? Because I would have added the exponents, right? I would have known that you have to add the exponents. So if we got x to the 3/5 times x to the 1/2, what are we going to do? We're going to add the exponents. 3/5 plus 1/2. Can anybody tell me what that is? LCD is 10. Then you got to find common denominator. You got to multiply stuff out, move stuff around. So you should end up with 11 over 10. 11 over 10. Y'all know how to add fraction, right? Yes. Y'all want to see me do it or no? No? Okay. So, like I said, find a common denominator, which is 10. Move some stuff around, flip some stuff over, and that's it. Okay. So that's all we're going to do there. Now, let's move down to number 10 real quick. Number 4, by the way, if you had to do number 4, 1/2 means what? To the 1/2 power means what? The square root of. So this really means the square root of 9x4y squared. Right? To the 1st power. And the square root of 9 is 3. Square root of x squared is x4 is x2. Square root of y squared is y. You're done. All right. Now, they will have a problem like this on here as well. They'll say write this with rational exponents. Okay? In other words, we just talked about the fact that if it's a denominator, it becomes an index. If it's a numerator, it becomes a power. Now we're finna go in reverse. What's the index on this thing right here? It's a 2 right there, right? So that must be your what? Numerator or denominator? Denominator, right? And what's the power here? We don't see one, so it must be what? So this really means what? 2 plus 5y to the 1/2 power. Doesn't it mean that? Yeah. Because we just said that the numerator is your power and the denominator is your index. So I'm just going in reverse now. My index must be my denominator and my power must be my numerator. All right, so if I had to do number 2 real quick, this would be 1 over 4x to what power? What power would that be? The cube root would be what power, though? 1 over 3, very good. Be 1 over 3. Now, I don't know if they would take that to negative, but they might write this as 4x to the negative 1/3 power, because it's at the bottom, and they might have flipped it back up. What are they doing that, Vic? You flip it back up? Okay. Then you'd have to put the negative. Because right now it's in the denominator. Remember, when you flip something, it changes negative. You know, you have a negative exponent. That makes sense or no?
It makes sense.
Okay. All right. Let's keep going. Oh, this is real easy. Okay, these will be real quick to go through. Number 11, domain and range. Next to domain, write the phrase x values. Anytime you see the word domain, that just means x values. So what's the domain on number 11? -7, 0, and 2. And we're done. Oh, sorry about that. Okay, again, domain simply means x values, range means y values. So in that particular problem, if they say, what's the domain? What is it? -7, 0, 2. And they say, what's the range? 8, 0, 4. And that's it. Done. Nothing else to do. Number 12, this is evaluating functions. Now, when you see f of -1, all that means is your x must be -1, or your x must be 0, or your x must be 2. They'll ask you. They're not gonna ask you for all three of them. They ask you for one of them. They might say, okay, what's f of 2? What does that mean? That means everywhere you have an x, you would put a 2, like that. And so that would be, what would that be, y'all? See if y'all know. Please excuse my dear Aunt Sally. Well, how much? -13, you said? Y'all agree? -13, he said. Or is it -61? Which one? Y'all got to have an opinion. Come on, tell me real quick. I know y'all already get it. -13? Yeah, because you square before you multiply. Very good. So you'd have 3 minus 4 times 2 squared, which is what? 4. So you'd have 3 minus 4 times 4. Well, 4 times 4 is 16. So you really have 3 minus 16, which is what? -13. And that's all you do. Same thing over here. You just plug them in. All you're doing is doing substitution is all you're doing. Everywhere you have an x, you'll put one of these numbers. They will not ask you all three of those. They'll say on the test, what is f of 10? Put in a 10 and see what you get. That's all you do. All right, find the slope. We got a formula for slope. You got to memorize this. The slope formula is as follows. Slope will equal to the change in y divided by the change in x. In other words, the slope is equal to the difference in the y values divided by the difference in the x values. Okay, so what do we do first? Label your points. So let's call this one, what do you want to call this one? X1, Y1. What do you want to call this one then? X2, Y2. Now can I change these? Can I call this one X2, Y2? It doesn't matter again. Doesn't matter which one you label. You cannot say X1, Y2 and X2, Y1. You can't do that. But you can interchange those points. So let's plug these numbers in for me. Tell me what to write. I'll be quiet. -13 minus 3 divided by 5 minus 1. Very good. Okay, -13 minus 3. -16. Very good. Divided by 4. -16 divided by 4. -4. That's your slope. You'll have one of those on the test. Y'all good with that? Okay, we're getting there. We are getting there. All right, real quick. Graph each line. Okay. Now, if I had to graph a line, of course you're not gonna make a graph on the test, right? So they'll ask you to graph. You're gonna have to match the equation with the graph. Real quick, if I were graphing number 1, got y'all can't see that. If I were graphing number 1, this is what I would do. You have an XY coordinate plane. And do y'all remember y equals mx plus b? Where m represents the slope and b represents the y-intercept, right? We also know slope is the same thing as what? Rise over run, right? Most of us already know that, right? All right, so how would I graph this particular problem? I would do this. I would say, okay, my y-intercept is what? 3, right? So I'm going to go 1, 2, 3, and put a dot. Put a point. Because my y-intercept is 3. Y'all see that?
It would be negative.
No, I'm dealing with this right here. Just the y-intercept. Now my slope is what? -3 over 5. Which means my rise over run is what? Down 3. 1, 2, 3. And over 1, 2, 3, 4, 5. I'll put another point. And there's my line. That makes sense? So I plotted my y-intercept first, and then I looked at my slope, and my slope was negative 3 over 5, so I went down 3 and over 5. If my slope would have been positive, I would have done what? Gone up 3, then over 5. Yes, no? Y'all looking tired now. We're almost done. Y'all too young to be tired. Okay, number 15, number 1, section 15, number 1. They want you to write the equation of a line that passes through the given points. To write the equation of a line, we need the formula of the point slope form of a line. Y minus y1 equals to m times x minus x1. You got to remember that. Y'all seen that before?
Yes.
Yeah? Okay. All right, here we go. The first thing we need to know is what the slope is. So I'm going to have to calculate the slope real quick. So I'm going to do that. Just kind of follow me. I'm going to calculate the slope real quick. The slope will be 2 minus negative 1 divided by negative 6 minus 3, which is 3 over negative 9, which is negative 1/3. See if y'all follow that real quick. 2 minus negative 1 divided by negative 6 minus 3. Yes, no? I get 3 over negative 9, which is negative 1/3. Now I'm going to go, now that I know the slope, I can now go over to the point slope form of a line, and I can plug these things in. Yes, ma'am.
Okay, you say y minus y1. When you have 2 right there, shouldn't it be like y2 minus y1?
No, not on this particular formula. This particular formula only uses x1 and y1. So, because you're going to leave the y here, but what is y1? Negative 1, right? What's the slope? Negative 1/3. And what's x1? 3. This one is kind of complicated. It's not complicated, but it's a little bit trickier than the others. So I got y minus y1 equals to the slope times x minus x1. But what's y minus negative 1? Isn't that y plus 1? And if I multiply this out, negative 1/3 times x is negative 1/3 x. Negative 1/3 times negative 3 is positive 1. Positive 1. Yeah, sometimes we do that. Sometimes I do that, sometimes I don't. Let me finish it this way, and I'll go back and do it that way. Okay, so I just multiplied everything out this time. Negative 1/3 x is negative 1/3 x. Negative 1/3 times negative 3 is positive 1. How do you get the y by itself? Subtract 1 from both sides. Y is equal to negative 1/3 x. And you're done. The other way you would multiply when you have a fraction of negative 1/3. That's what you. Who asked me that question? Yeah. You could multiply everything by 3 from the beginning. 3 right here, 3 right here, 3 up here, and then it still works out the same way. You'll still get the exact same answer. So sometimes I do that, sometimes I don't. Okay, let me skip down. So that's a look at how they work. Let me do number 4 real quick on 16. 4 and 5, and then we're almost done. Okay, number 4 says that I want the equation of a line that's parallel to y equals 3x minus 4, but it goes through the point 1, 5. All right, so this is how we get started. What is, on number 4, what is the slope of this line right here? Y equals 3x minus 4. What's the slope? The slope is 3, isn't it? Okay, tell me something about parallel lines. What do you know about the slopes of parallel lines? They what? They never come together, but what about the slopes? They will always be the same. And like he said, 2 parallel lines, they never touch. Some mathematicians believe at some point they do touch. But that's something totally different. But 2 parallel lines never touch. So if they don't touch and they have the same exact slant, that must mean they have the same exact slope. So parallel lines have the same slope. So we're going to use m equals 3, and we'll use the point 1, 5. So we'll go back to that formula again. Y minus y1 equals to m times x minus x1. And we'll just plug them in. I'm not going to finish it. So tell me what to write. Y minus what? 5, because y1 is 5, right? Equals to m. What is m? 3. And x minus x1. What is x1? 1. Then you can finish it from there. Y minus 5 will equal to what? 3x minus 3. Add 5 to both sides of your equation, right? And y would equal 3x plus 2. I'll let you finish that. Now, perpendicular. Now, what do you know about perpendicular lines? They intersect. But when they intersect, they form a right angle. What do you know about the slopes of perpendicular lines? Well, first of all, let's find the slope of this one, number 5. Let's find the slope real quick. I cannot find the slope until I isolate the y. So let's isolate the y. I'll move this 2x to the other side. Can y'all see that? Yeah. So what do I have? Negative 3y equals to negative 2x plus 1, right? Divide both sides by negative 3. And I know that y is equal to negative over negative is positive 2/3 x minus 1/3. So what's the slope of this line? Positive 2/3, right? Now, do you want to use the positive 2/3? No, because that means that it would be the same. The slopes of perpendicular lines, their slopes are called negative reciprocals of each other. So what is the negative reciprocal of 2/3? Negative 3 over 2. So that's what you're going to use as your slope, and that's the point you're going to use.
Repeat that, please.
Yeah, perpendicular lines, their slopes are negative reciprocals of each other. So if you know, in other words, if I have a slope, let's say that I know my slope is negative 3 over 4, and I tell you that the lines are perpendicular, then the next slope will be what? Positive 4 over 3. Always the opposite flipped over.
So what if you have like one single number, like say your slope from the first one is 4?
So what if your slope is 4 from the first one, and you want one perpendicular to that? What would it be? That's a good question. It will be negative 1 over 4. Why? Because 4 is really over 1. So when you flip it over, it'll be 1 over 4, but the opposite. Yes, sir. No. Flipping it and negative are going to be two different things. Flipping it over just means you turn the numbers upside down. Negative means you change the sign. Oh, okay. You think about negative power, right? Okay. Yeah. Yeah, that's totally different. Okay, let's keep moving. They wanted us to look at 17 and 18. Oh, let's look at 18 real quick. Y'all should be able to do number... in order to do number 17, they say, does this line pass through this point? All you'd have to do is identify this as your x and your y, right? So then you would just simply plug them in. You would go 3 times x. What is x? 3. Minus 2 times y. What is y? And see if that's equal to 11. Well, 3 times 3 is negative 2 times negative 1 is positive 2. 9 plus 2. Yeah, so that point goes through there. In other words, you plug in the x value and the y value, and if it gives you a true statement, then you know that it goes through that particular point. Y'all good on that? Okay, here, number 18, this is important. They want to know, what is f of 3? What does this 3 mean? What value? Is that the x or the y right there? That's the x value, right? So go on the x-axis and find 3, which is right here, right? And then do what? Go up there, and where does it touch? That's your answer. It touches at the 4. Does that make sense? F of negative 1. That's your x or your y? That's your x. So go to the x-axis and find negative 1. Where does it touch the line? Right here. What is that? 0. The y value. In other words, if they give you the x value, they want to know the y value. They're not going to give you the x value and say, well, what's the x value? If they give you the x value, then they want to know the y value. So when the x value is 3, the y value is 4. When the x value is -1, the y value is 0. If I wanted to know f of 2, what's the value of f of 2? F of 2? Find the x value, which is 2. The y value is 3. We're done with that. Okay? A couple of word problems and we can get out of here. All right. I'll just do a couple of these and we can be done. Okay. You will have a couple of word problems on the test. You're not going to have a whole bunch of them, but you will have a couple. And don't just give these points away. You can do these problems. Number 1 says, if an even number is squared.
Can't see it.
Oh, you can't. I'm sorry. I guess I'm getting tired too. All right. If an even number is squared, the result is 4 more than 3 times the number. What is the number? So my question is, what is the number? Do you know? Do you know what it is? You don't know what it is, right? So we call it x, right? When you don't know what something is, you call it x. Okay? So if a number is squared, so that means I don't know what it is. So if I take any number and square it, so if I take x and square it, the result is, you know what the word is means in mathematics, right? Equals to. So x squared is equal to what? 4 more than, that's going to be plus 4. 4 more than what? 3 times the number. So 3 times the number would be 3x plus 4. So that's how you would set it up. So this number squared will equal to 4 more than 3 times the number. Now how do we solve this? Move everything over, set it equal to 0. I'm going to do that real fast. X squared minus 3x minus 4 equals 0, right? Y'all agree with that? Just moving the 3x over, move the 4 over, you get negative 3x minus 4. Can we factor this? Here we are at the end of this test, and we are still factoring. All right, so here we go. X squared minus 3x minus 4, that's going to be x minus 4 and x plus 1 equal 0. Y'all agree? All right, let's solve this for 0. If x minus 4 equals 0, x must be equal to what? 4. And if x plus 1 equals 0, x equals what? -1. So those are my 2 answers, right? But what did they say in the beginning? If and what? Even number, which allows me to do what? Eliminate that negative odd number. So the correct answer is 4. That makes sense? All right, if I were doing number 2 real quick, I'm going to set up a nice little proportion right here. I got a truck. I can go 180 miles on 12 gallons. So 180 can go 12, uses 12. Well, how many miles can I get on 15? In other words, I can go 180 miles on 12 gallons of gas. How many miles can I go on 15 gallons of gas? I set up a proportion. How do I solve that? Cross multiply. 12 times x equals to 180 times 15, 2,700. Right? Is that right? Okay. Now, divide both sides by 12, and I don't want to do that right there. Y'all get the idea. All right? Y'all can finish that one. All right. That's pretty much it. Let me do, and y'all can do the rest of them. Okay, let me do a right triangle. Number 8, 19, number 8, and we'll be done. Y'all been a great audience, by the way. I hope y'all pass y'all test. Somebody say, hey, praying. The Lord works wonders, man, sometimes. All the time. But it ain't gonna help you if you ain't studying. Don't sit there and pray and think you're going to work a miracle. And you're going to go in and make 100. You got to study. Huh? Well, that's true. It can happen. Don't count on it, though. Don't count on that. All right, number 8 says, find the length of the hypotenuse. Now, the reason why I put the 5 and the 12 here is because it said the 5 and the 12 were the lengths of the legs. The legs are always adjacent to the right angle. the hypotenuse is always the longest one that is opposite the right angle. So I am looking for this one right here. Now in the test, they could actually give you the hypotenuse and not one of the legs. So you got to be careful. But in any event, we're going to use Pythagorean's theorem, right? Which says what? A squared plus B squared equals to C squared. Right? We learned that also in 8th grade or somewhere. Now, what is A? Now, A and B are interchangeable. It doesn't matter which one you let be A or B. That doesn't matter. So we're going to let A be 5 this time. So that's going to be what? 5 squared plus 12 squared equals to C squared. Well, 5 squared is what? 25. Plus 12 squared. 12 times 12. 144. Very good. Equals to C squared. Well, 25 plus 144. 169. That equals to C squared. But we're not done because they don't want to know what C squared is. They want to know what C is. How do we get rid of something squared? You take the square root of it. So what's the square root of 169? C equals to 13. And you are done. And we know the length of that leg is 13. All right, good luck on your test.